Yo, what up? Calculus students. Let's get into motion. Heads up. Calculator next class. I was thinking about how am I going to get this across, but I figure making a homework video right now and saying, yo, bring your calculator next class. You need a calculator. You have to have a calculator for lesson 2. We're good. Bring calculator next class. And for the remainder of the year, just bring your calculator because we'll start using it more. Here we go. We are talking about physics and motion. And what we discovered is that you start with a position. Now, it's going to be confusing with these number lines, but there's 2 different number lines that we're going to talk about. We're going to talk about a dude on a number line moving, where we have positions and time is kind of floating up here. We'll have another number line where we do a sign analysis where like time is on the x-axis and it's not showing you where the guy is. We'll try to make sure we distinguish the 2 because I think that's a big cause of confusions. What we talk about is that if we're looking at the slope of position, so how your position is changing, your position went from 2 to 8, okay? Your position increased by 6 over the time 2 seconds. So 6 meters per 2 seconds. We get this 3 meters per second. The rate of change of position is what I just calculated, the rate of change of position. Well, physicists have used the word velocity when they could have been using the rate of change of position or the derivative of position. The derivative of position, how quickly position's changing, physicists use velocity. Then we could do the same thing to realize that how quickly velocity is changing would give us an acceleration in meters per second. And what we realize is that the rate of change of a rate of change is an acceleration of position. The rate of change of a rate of change of position is acceleration. The rate of change of position is velocity. We get this idea, and probably is the easiest thing to talk about, where we have f prime, f double prime. We are used to something, its rate of change, and the rate of change of its rate of change. Well, we have this position whose rate of change is a velocity, whose rate of change, whose rate of change of velocity, we use the word acceleration. Okay, so this unit, this first lesson, is a repeat of Unit 3 and a little bit of Unit 6, just with different words. Okay, so let's get into it. First things first, this is a bad equation. Trying to think about how I can change this. So change this to a plus 3t. Okay, now do the question. What's the average rate of change of position from 0 to 2? It's just like quickly understanding like slopes or rates of change. Average rate of change would be a slope of the secant. Honestly, before we go into anything, let's just make sure we understand what's going on. Guys, the derivative. That'll work. The rate of change of position is velocity. We just found an equation for velocity. Not worrying about any questions, just like understanding what's going on. Now, understanding a sign analysis of this. A sign analysis of V talks about times. This is different from, hey, this is what's happening with my dude who's moving to the left and to the right. These are now positions, and time floats above his head. So make sure you understand, like we remember the guy moving back and forth, but this is really just the guy moving back and forth is like the graph that we used to kind of sketch, but I don't want you to sketch the graph. So maybe don't even think about the guy moving back and forth. unless you really know what's going on. Two different things. Let's see if we can figure it out. I'll show you. Okay. Uh, we could take the derivative of this, realize, oh, a rate of change of a rate of change in of position, physicists have called acceleration. Okay, now let's say we wanted to do a sign analysis. Cool. This is a second derivative sign analysis, or it's the derivative of v sign analysis. The second derivative tells me about a first derivative, or it tells me about v, right? Like both goes, it's like second derivative tells me about the first derivative, while a tells me about v. The first derivative tells me about x. X prime will tell me about x. Now I could factor out a 3 and I get t squared minus 2t plus 1. I could factor this to be t minus 1, t minus 1. So I get 1 for both. Minus 2t plus 1. That works. All right. Cool. If you did a sign analysis of your x prime, you get positives and then positive. That's good. It's good, but it's not good. It's t minus 1 squared. If I plug in 3, positive, positive. If I plug in 0, it'd be negative, negative. So I go to the right, I slow down, I stop, I go to the right. If I look at my acceleration, I got positives, then negatives. Okay. Being able to do this is something we've done before. It should be like easy to understand / do. The only difference is, x prime tells me about my position increasing or decreasing. It tells me if I'm going right or left. Here I'm going to the right. I stop. If position increases, I go to the right. Here, if my second derivative tells me about the first derivative, my acceleration tells me about velocity. My velocity is decreasing, my velocity is increasing. We kind of stop it there. We can talk about then speed. When are we speeding up or slowing down? This is actually perfect for speeding up and slowing down. Boom. Here is the exact equation for velocity. It's just the rate of change of position is the derivative position. Here is the exact equation for acceleration. It's just the rate of change of the rate of change. Cool. I'm going to come back to the average rate of change. What is the velocity at time 1? What is the velocity at time 2? I already found the velocity at time 1 is 0. Velocity of time 2, again, I changed this to plus 3t so that we can factor it. I get 8 minus, sorry, I don't get 8. 12 minus 12 plus 3, I get 3. All right, what does that mean? At time 1, my velocity is 0. That means my rate of change of position is 0, which means my position is stopped. My rate of change of position is 3. That says at time 2, my position is increasing 3 meters per second. This is like the y's per x kind of deal. Meters per second. What is the acceleration at 1? All right, the acceleration of 1 is 0. What's the acceleration at 2? The acceleration at 2 is 6. At time equals 2, my velocity is increasing at 6 meters per second squared. It's probably important to say that, like my position is meters, taking the derivative would be meters per second with respect to t. If my velocity is meters per second, taking the derivative would be meters per second per second. When is the particle moving to the left? Never. The velocity is positive or 0. It's moving to the left when the position is decreasing. The position is decreasing when the velocity is negative. You're just going to get this in your head because when a derivative is negative, something is decreasing. My position is negative. When my derivative is negative, my position is decreasing. When is the velocity increasing? The velocity is increasing when its derivative is positive. The derivative of velocity is acceleration. We found when the acceleration is positive, it's for t is greater than 1. When is speed increasing? Now, we talked about this, and it's very tough to see, but like if you look at the dude helps you. If your velocity values are getting further away from 0, you're speeding up. Let's think about that. Further away from 0. 1, 2, 3, 4, 5, 6, 7. That's getting further away from 0. I'm speeding up going to the right. My velocity is positive and my velocity is increasing. Okay? That means my first derivative is positive and my second derivative has to be positive. For my velocity to go up, its derivative has to be positive. That means a is positive. That's x double prime is positive. Okay. Speed increases when the values of velocity are getting further away from 0. What's another way to get further away from 0? -1, -2, -3, -4, -5 are velocity values that are getting further away from 0. That's when your velocity is negative and decreasing. Your velocity would be decreasing when acceleration is negative, negative, and negative. What do we notice? The signs are the same. Speed increases when the signs are the same. You could be speeding up in either direction, going to the right or going to the left. So what we can either do is remember that. You're going to have to justify eventually, and your justifications must be V and A have the same sign. That's it. It's that simple. You don't have to go into why V is X prime and why A is X double prime. Boom, we're just good. V and A have the same sign for values greater than 1. Here I'm slowing down until 1, I stop, and then I start speeding up after that. Because I'm going to the right, slowing down, stop, going to the right after that. The last question is the average rate of change of position. This is kind of just how we introduce the idea of rates of change of position, give you velocities. X of 0 is 0. X of 2 is 8 minus 12 plus 6. It's -4 plus 6, which is 2. So it's something that we don't do often, actually, is do these slopes of the secants, but we remember average rate of change, use the slope formula. It's the whole mean value theorem. Remember the mean value theorem? It's slope formula and derivative, average rate of change, instantaneous rate of change. So we should be thinking y2 minus y1 over x2 minus x1, but remember, it's not y's and x's, it's positions and times, where positions are on the x-axis. My cursor disappeared. So x goes to x prime, goes to x double prime. That's x VA. Sign analysis of V and A will tell you about how x is changing and how V is changing. And you can answer all these physics-related questions just by understanding what you did back in Unit 3 with your function analysis. All right. It works going the opposite way, but don't forget the key thing. If you go backwards, if you take antiderivatives, you need plus C. Let's go backwards. This is x double prime, which is V prime. I go backwards one step, I'll get to V, which is x prime. I get t squared minus 4t plus a C. Cool, don't forget about that. C. Oh, I'm given some information. Initial velocity and initial position. Initial means when t equals 0. You're going to see that a lot. Just know that's when time is 0. That means your velocity at time 0 is 3. That means your position at time 0 is 4. Okay? Here we go. Velocity at 0 is 3. If I plug in 0, I get that C is 3. That should make sense. I should not have to show you that. Go backwards again. you get x. X would be 1/3 t cubed minus 2t squared plus 3t plus c. X of 0 is 4. X of t equals that. Crazy. Do a sign analysis for V and A. All right, well, I already have A. All right, so let's do our sign analysis for A and understand what it means. Sure, right here. Let's do it right here. A is the derivative of V. It's the second derivative of X. It tells me about the concavity of X, which I actually don't care about, but it tells me more importantly that it's how quickly V is changing. I set that equal to 0. I get a 2. Remember, solve. You got to do it. Don't just copy this down because I put it down. 2t minus 4 equals 0 when t equals 2. Plug in test points. I get positives if I plug in something greater than 2. Negatives. That means velocity is decreasing, then increasing. Let's go with v. T squared minus 4t plus 3. That factors to be t plus 3, t minus 1. Sorry, t minus 3, t minus 1. That's good. So I get zeros of velocity at 1 and 3. This is my first derivative, which tells me about how my position is changing. This is velocity. It's positive, negative, positive. My position is increasing. I'm moving right. My position is decreasing. I'm moving left. Think about the guy. I should probably go to the lesson. Think about the guy. I don't want to go to the lesson because maybe like this sign analysis is going to confuse you with the guy on the thing. Well, let's talk about this. Yo. Eventually, we are going to look at our specific positions at these times. We could do that right now, where it's like, what is x of 1? Well, if I plugged in 1 into x, I'd get a value. This is where I get located. When I plug in 3, I'm going to get a value. This is where my location is. This is telling me, along with this, that, and again, I'm switching gears from sign analysis to my motion analysis. Let's see if this makes sense to you. At time 0, my dude is at a position of 4. Cool? This is position, but this is time. T equals 1, time. Cool? My dude moves to the right till he gets to some position at time 1. My dude's position decreases. He starts moving to the left until he gets to his position at time 3. If I had time, I'd plug in 3 and get it. And then my dude finishes off by going to the right for forever and ever and ever. That's the idea behind this sign analysis, which is on a time axis, telling you what's happening on this analysis, which is on a position axis. Cool? In the future, we will be paying attention to which positions we're going to and how we're going to find those positions, okay? So this is time 0, time 1, time 3. What is the velocity at 2? Well, I have my equation for velocity. I get 4 minus 8 plus 3, which is negative 4 plus 3, which is negative 1. So at t equals 2, my position is decreasing by 1 meter per second. That's what it means. It means I'm moving left. Oh, well, they wanted me to find the position at 2, 3. I don't really want to, but let's find the position at 1 and 3. When I say we, I made this homework a while ago. I updated the future homeworks from this unit because I changed up this unit to make more sense. Hopefully it will. So When I say we, I'm really meaning myself. All right, well, this is going to help us understand what happened. 9 minus 18 plus 9 plus 4. All right, well, that's easy. That's 4. X of 3 is 4. X of 1 is 5 plus a third, 16 thirds. Okay. What happened with the dude? This is telling you how position is changing. Here are some position. My position at time 1 is 16 thirds. My position at time 3 is 4. We're going to be doing this more in the future. My position at 0 is 4. So switching gears to a motion analysis so we understand what happens. We start at a position of 4 with t equals 0 floating above our dude. My dude moves to the right till he gets to a position of 16 thirds. This position of 16 thirds occurs at t equals 1. My dude moves to the left till he gets to a position of 4. Oh, look at that. He goes back to where he started. Okay, never mind. My dude moves to the left and returns to his position of 4 at t equals 3. My dude then goes off into the distance to the right there. This telling us about the motion here. T-axis, position. T, position. Position axis. On the last period, I realized, oh man, that's confusing. Is the particle moving towards or away from the origin at time equals 2? Well, we know my positions are positive, all my positions, because like I hit this minimum position of 4 when I plug in 3. 9 minus 18 plus 9. Yeah, so I know my positions are positive. I probably should find the actual position because if you know if you're going towards or away from the origin, it's like a position of 0. This is the origin. Am I getting towards, am I going closer to a position of 0? Well, I plug in 2. My position at time 2 is 8 thirds minus 8 plus 6 plus 4. 8 thirds minus 8 plus 6 plus 4. And I get 10 minus 8, which is 2. 2 is 6 thirds plus 8 thirds, 14 thirds. And that makes sense. Okay, now, again, what does this mean? When time is 2, I am located 14 thirds to the right of the origin. Cool. I know when time is 2, my velocity is negative. My velocity is negative 1. Now, this is my position. This is how my position is changing. My velocity is negative. My rate of change of position is negative. My position is decreasing at that rate. So positive position that's decreasing, we're getting closer to 0. We are right of the origin, but we move to the left. So we are going towards. Hopefully we understand that. Like with this unit, a lot of times getting the answers is easier when you like have things memorized, but you won't really appreciate it until you really try to make sure you understand what you're doing. I went through this when I like taught this over and over again. It's like I kept being like, like you guys have to I'm like I used to teach like, oh yeah, just do this. I don't want to do that anymore. It's not rewarding if you're not understanding what you're learning, you're just doing stuff. Particle stopped when the position is neither increasing nor decreasing. That's when the derivative is 0. When your velocity is 0, that's at 1 and 3. Particles moving right. When the position is increasing, the position is increasing. I should have just drawn this better. mean, it doesn't matter now. We usually start time at 0, but sometimes we'll talk about time being negative, meaning like in the past. We found x of 0 is 4. We know x of 1, we'll be doing this more often, is finding these positions, 3. We haven't really cared about positions or like y values in the past, but we will now. We go back to 4, we go off for forever. My position increases, decreases, increases. Right, left, right. I'm moving to the right from 0 to 1, or t's less than 1, and t's greater than 3. My velocity decreases when its derivative is negative. Acceleration is the rate of change of velocity. When the rate of change of velocity is negative, velocity is decreasing. T's less than 2. Is acceleration increasing or decreasing always? So this is fun. Yo, I haven't asked this question ever. Is this increasing or decreasing always? Yo, I'm taking you to an unknown world. What is acceleration's derivative? The rate of change of the rate of change of the rate of change. Not even a word is given to it. But A prime is 2. A prime is positive. A must be increasing. Yo, that's V double prime. That's X triple prime telling you about V prime or X double prime. This is what calc is all about. When is the speed decreasing? Okay. When your velocity values are getting closer to 0, I'm getting closer to stopping. I gotta shut this door. Okay. When will our velocity values get closer to 0? When my velocity values are positive, but going down close to 0. 5, 4, 3, 2, 1, 0. Okay. So, can you shut that door? Can you just shut this door for me? Thanks, bud. Perfect. When velocity is positive and acceleration is negative, my velocity will be positive and decreasing, getting closer to 0. When my velocity values are negative, but going up. Now, that means -5, -4, -3, -2, -1. Getting closer to 0 is getting closer to being stopped. That's slowing down. I hope that makes sense. I've taught this so many different ways with so many different focuses. If I'm going to the right, but my velocity values are decreasing, if I'm going to the left, but my velocity values are increasing. Signs of V and A are opposite is what I used to just teach and say, hey, memorize this. But I hope you understand it. V and A are opposite signs. Here's V and A. Opposite signs. Probably should stack them on top of each other, to be honest. Positive, negative, positive. This is not a motion analysis. This is times. This is time equals 1. This is time equals 3. This is not position. These are times. This helps us understand how my dude is moving on a different axis with his position axis. It's going to be okay. My velocity values, my acceleration values are positive and negative. That means my velocity is increasing, decreasing here. So my velocity is positive, but decreasing. That means my velocity values are getting closer to 0. You can say -infinity 1 or t less than 1. My velocity values are negative and increasing. My v is negative, my v is increasing. Negative and increasing. -5, -4, -3, -2, -1. My signs are opposite. My velocity values are getting closer to 0. Yo, this is the graph of a velocity. It's the graph of a derivative, right? When is the particle stopped? When your motion is stopped. When your motion is neither increasing or decreasing. When your velocity is 0. 0, 3, 5. When is the particle moving left? Remember, something moves left when its position is decreasing. My position is decreasing when its derivative is negative. Its derivative is given to me here. I need to figure out when this graph not is decreasing. No, velocity decreasing is something else. When this graph is negative, the graph is negative between 3 and 5. When is acceleration negative? Oh, acceleration being negative is the derivative of velocity being negative. The derivative of velocity is negative when velocity is decreasing. You want to figure out when acceleration is negative, you figure out when velocity is decreasing. This is the whole x double prime tells us about x prime's direction. I want to know when x prime is going down. That's between 2 and 4. Signs of V and A are opposite. I'm going to show you 2 different ways to do this. Or understanding velocity is speed is just velocity without direction. You can think about the magnitude of your velocity values getting bigger. Or getting further away from 0 means you're speeding up. Getting closer to 0 means you're slowing down. Doesn't matter the direction. You can say, when is your velocity positive and decreasing? Or you could say, when is your velocity negative and increasing? Okay, positive and decreasing, negative and increasing. Positive and decreasing, negative and increasing. What do I just see here? What do I see here? This is the interval in which my velocity values are getting closer to 0. I'm going towards a stop. Now, you're not allowed to say for your justification, my velocity values are approaching 0. Yet say velocity and acceleration signs are opposite. That's acceptable. But it's 2 to 3 and 4 to 5. Next question. When is the particle stopped? Velocity 0, 1, and 3. When is the particle moving left? When my position is decreasing. When my derivative is negative. This is a derivative. Now, it's not when it's decreasing. It's when your derivative is negative. It's when your velocity is negative. My velocity is negative here and there. I'm not going to include 2 or 3. It's going to be 1 to 3 and then 3 to infinity. When is acceleration positive? Okay, that's the whole f double prime, f prime. X double prime tells me about x prime. A tells me about v. A being positive is when v is increasing. V increases here, 2 to 3. When is speed increasing? V and A have the same signs. V and A have the same signs. Okay, when do V and A have the same signs? When your velocity is getting bigger, when it's getting further away from 0. Both directions. I'm either speeding up going to the right or speeding up going to the left. Here, my velocity is negative and decreasing. The signs are going to be the same of V and A. Here, my velocity is negative and decreasing. There are no points when my velocity is positive and increasing. 1 to 2, 3 to 4. Now, the rest of this homework introduces you to free response questions that you may see. You don't have to do all the questions. You can't. Notice, for the rest of the homework, it's just quick little parts that you can do, okay? We want you to do them. The last lesson of this unit is just like one quick little thing, and then you do an entire free response questions as like homework / reviewing / studying for your test, okay? I don't know if I've even made that homework yet. I think I have. I don't even know anymore. I've been doing a lot of work. Anyways, when is the particle moving to the left? This is an exact free response question, A, B, C, D, 9 points. You'll see you're not going to be intimidated because you're going to crush this problem when you get a question. Every year there's a motion question, so we're going to be ready for it. Particles moving to the left when my position is decreasing, when my velocity is negative. They gave me a velocity. I got to figure out when this is negative. I got to take my velocity and set it equal to 0. The best ways to do this problem, what we did back in the day is replace it with a y. And then we're like, okay, when does cosine equal 0? This is back from unit 0. Cosine equals 0 at the verticals. But understand that we don't want y's, we want t's. And we multiply everything by 6 over pi. This is one way to figure this out. Probably the best way is to know it's like, oh, I want pi over 2. I have 3. Oh, I want 3 pi over 2. I need a 9. 6 divided by 2 is 3 times 3 is 9. This works out in that it's between 0 and 12. We do a sign analysis with 3 and 9 of our derivative. Sorry, this is v is given to me, which is the derivative of x. It's going to tell me about x. If I plug in 0, I get the cosine of 0, which is 1. If I plug in 4, I get the cosine of 4 pi over 6, which is 2 pi over 3, which is negative. If I plugged in 6, it's the cosine of pi, which is negative. If I plug in 10, it's the cosine of 5 pi over 3. It's back to being positive. So when are we moving to the left? 3 and 9. Give a reason for your answer? No. Okay. Part C. Find the acceleration of your particle at time t. Is your speed increasing or decreasing or neither at t equals 4? Okay. V prime equals A. Okay. We want an equation for A. We're going to have to take the derivative. I got to O and I this. I got cosine parentheses. I got pi over 6 t. The derivative of cosine is negative sine. The derivative of pi over 6t is pi over 6. A equation would be negative pi over 6 sine pi over 6t. I took a derivative. You remember taking derivatives? They're back. They're back. I take a derivative. That's a big thing for this. Making sure you don't mess up derivatives and antiderivatives, because we're going to be doing both in both directions. Plugging in 4. Don't have to do a full sign analysis, though you could. If you plug in 4, you get negative pi over 6 sine of 4 pi over 6, which is 2 pi over 3. The sine of 2 pi over 3 is root 3 over 2. This is a negative value. So your acceleration is negative, which means your velocity is decreasing, because this is the whole f prime till f double prime tells us about f prime. You know your velocity is negative. Your velocity is negative. Your velocity is decreasing. Your velocity is negative and getting further away from 0. Negative and getting more negative. Signs of V and A are the same. We are speeding up. Cool. Yeah. This is going to be very similar to a free response question you have on your actual test. I'm going to give you two particles, an A, a B, a P, and a Q. We got the position of particle P. We got the velocity of particle Q. Ooh. What is P moving to the left? When its position is decreasing when the velocity is negative. Boom. That's when the derivative of position is negative. Rate of change of position, we call velocity in physics classes. Thanks, physics, for using more words that we have to understand. So the rate of change of position, which is my velocity, is, okay, I got to O and I this. I got log parentheses, and I got t squared minus 2t plus 10. The derivative of log parentheses is 1 over parentheses. The derivative of that is 2t minus 2. So I got 2t minus 2 over t squared minus 2t plus 10. I have to somehow do a sign analysis for this and set this equal to 0. Just remember, you got to figure out when you're 0 or undefined, those are your possible sign change points. I don't think I can factor this. I think this has to be greater than 0. I really think that t equals 1 is the only time when my derivative equals 0. That's tricky. Why would they do that? Give you something like that that you can't factor. I haven't done this question in a while. They're going to make a lot of students feel like, oh, I'm doing something wrong. But we're going to go ahead and say that this is only positive. You can do the discriminant b squared minus 4 times a times c. Realize it's negative, which is obvious. So anyways, there's no solutions from there. This is positive. What a trickiness. They're usually not this tricky. Anyways, if you plug in 2 positives, if you plug in 0, that's going to be negatives. That means my position is decreasing then increasing, which means I'm moving to the left when t is less than 1. Part B, when do the two particles travel in the same direction? All right, well, I need to analyze the signs of v of q. Again, that would be the derivative of position, the rate of change of position. And I'm going to factor this to be t minus 5, t minus 3. So here's my v of q with 3 and 5, positive, negative, positive. That is telling me my position of q is increasing, decreasing, increasing. When are we traveling in the same direction? My velocities have the same signs. My rates of change of position are the same. From 0 to 8. Should look at them on top of each other, but you can see before 1, after 1. So that would be from 1 to 3, and then from 5 to 8. Part C, find the acceleration of Q. Okay, like here's the acceleration of Q, 2t minus 8 at 2. A, Q. Again, how did I get that? Obviously, the rate of change of velocity, meters per second, meters per second squared. Acceleration, we got this. This is like x prime, x double prime. A at 2 is negative 4. Are we increasing or decreasing or neither? My velocity at 2 is positive. So I have positive velocity values. My acceleration is negative, which means my velocity is decreasing. Or velocity and acceleration are going in opposite directions. I'm slowing down. The easiest justification, because they ask you for justification, and well, they usually do. Yeah, explain your reasoning. The easiest reasoning is always velocity and acceleration have opposite sides. It's easier than saying, oh, my velocity was positive, but since acceleration is negative, my velocity is decreasing, which means my velocity values are approaching zero, which means I'm slowing down towards a rest. Oh, man. I don't want to get a calculator out. You won't have a calculator for your quiz, so we're going to go ahead and skip this. We'll talk more about calculator stuff next class, okay? Lots of calculator stuff next class. Lots of calculator stuff next class. Your quiz is no calculator, so I'm not going to break out the calculator yet. So skip these last two homework questions. If you did not watch this video and you got to these questions and you're like, oh, I don't know what to do because we're going to use a calculator. I'm sorry, but we'll start using our calculator next class. So everybody, heads up. Calculators next class. Mr. Messner, out.